Let's take a look at example number 4. We have z squared plus 10z plus 16. We're starting to deal with a little bit bigger numbers here, and that's okay. So the number in front of the z squared is a 1, and the 16, so if we multiply it together, we get 16. Factors of 16, 1 times 16, 2 times 8, 4 times 4. And then we have our negatives as well. Negative 1 times negative 16, negative 2 times negative 8, negative 4 times negative 4. Now, you might be wondering, why are we doing negatives at this point? Well, as we keep going, we're going to be dealing with negatives, so we're going to have to come up with those values as well when we're looking to factor. We want to find which pair adds up to positive 10. That's this pair right there, the 2 and the 8. Okay, so we could go through and we could add, these two add to 17, these 10, this is 8, negative 17, negative 10, negative 8. We want the positive 10 part. And so we do z squared plus 2z plus 8z plus 16. Now again, remember, we could do the 2 and the 8 interchanged. Okay, so we can flip-flop them. That totally works. It's just important that we do the rest of it correctly here. All right, so let's factor out a greatest common factor from each of these sets. Z squared plus 2z, we can take a z out. And you might start to see a pattern that's forming here. Okay, z plus 2. And in this case here, we can take an 8 out of each. So we're going to have an 8, positive 8, z plus 2. 16 divided by 8 is 2, and 8z divided by 8 is just z. You'll notice there, z plus 2 is one of our factors, and z plus 8 is the other factor, and those are our two binomials which multiply to get our trinomial. Now, some of you may have seen a bit of a pattern forming over these last 4 examples, and I want to go through that pattern as it might help you to figure things out a little bit quicker with these trinomials. Now, we're going to be dealing with more complex ones later on, but for now we can take a look at some of the easier little tips and tricks here. So I'm just going to go back to number 1. The factors that worked were 3 and 4. So we split up 3 and 4. Here we get 3 and 4. The factors that worked were 1 and 1. Here we get 1 and 1. The factors that worked were 1 and 3. Here we get 1 and 3. Factors that worked were 2 and 8. Here we have 2 and 8. You'll notice that it's going to work out that way every single time when we have a 1 in front of our x squared term, or in this case our z squared. So if a is 1, or if this is a value of 1, we can always just find the pair that multiplies together to get the 16 in this case, and put them in behind the z. So we're going to have a z plus 2 and a z plus 8. So that's just one way to think about it. As what's happening, okay, the z's multiply together to get z squared. The 2 and the 8 multiply together to get 16, and they're going to add, because we do 8z and 2z, they're going to add to get 10z, and that's where we get our middle term for. So if you see that as a pattern that's forming, you can gladly use that, especially if we don't have a number in front of the z squared, in this case, or x squared in kind of our generic case. If there is a number in front there, then we have to do our decomposition again and go through that process.